Okay, so yesterday we looked at the aperture stop of a system, and I hope you began to see how important this element is. We also looked at how you calculate which element is the aperture stop. So if you have an optical system and you have many elements in it, one of them is going to act as the aperture stop, and we saw how we could calculate which one it was. We then moved on to looking at what are all the different functions that get affected by the aperture stop in the system, and we saw some important features. For example, we saw the depth of field of the system, the depth of focus of the system is affected by the aperture stop. This image here is how we ended the class. So we said if you had a set of objects and this was along the optical axis, then you could tell which was a setting of the camera in order to have obtained such images, and the one with the larger depth of field, that means it's capturing objects spread along the optical axis better, must have a smaller diameter, in other words a larger f number. So if you were to ask whether this was a f/2 system or a f/16 system, the upper image clearly must have been taken with the f/16, the larger f number image, and that also we understood implies that the exposure time would have to be longer, because f/16 is a slower lens than an f/2 lens. Okay. So I want to give you an exercise to do today. So you've been given a sheet with this picture, and we need to trace two rays through the system. So I want you to trace through two rays through the system, the chief ray and the marginal ray. Okay. So take a look and see how you would trace these rays through the system. Now to trace the ray, clearly you must understand it isn't necessarily going to be that you can trace one ray starting from the object and then trace it all the way to the end. The ray bends as it travels through the system. So there are different, it has a different slope in every section of the system. It may be that you have to trace the end of the ray before the start of the ray. Okay. This is just an exercise to see if you have understood the concept of the aperture stop, the pupils, as well as the chief ray and the marginal ray. Okay. Now, what is it that you do know about the chief ray? What can you say about the chief ray? It should arrive at the extreme point of the image, appearing to come from which point? The exit pupil, right? It is going to appear to come from the center of the exit pupil, right? So I can draw then this. So here's the center of the exit pupil, right? Obviously the ray is not really coming from there, but if it were, and this is really putting my skills as a what we wrote over here, the center of the chief ray goes through the center of the aperture stop. This is not wrong, but I need to be careful whether the entrance pupil and the aperture stop are one and the same thing, right? Because I know that the chief ray goes through the center of the entrance pupil, isn't it? So this is not incorrect. But it also goes through the center of the entrance pupil. The system has three lenses and an aperture stop. So the aperture stop lies between this lens and this lens. Because there are lenses both before and after the aperture stop, that means that there is an image of the aperture stop because of this lens 1. This lens precedes the aperture stop, so its image creates the pupil. But there are lenses after as well, right? You have not been asked to calculate the exit pupil here. So, someone has done that calculation and found out where the location of the exit pupil is, exit and entrance pupils are. So, here they have found out for this system, given the focal lengths of these lenses, that the entrance pupil lies over here, right. So, my first ray actually has to be drawn going through the center of the entrance pupil, right. So, I actually need to draw a ray that's doing this, okay. This is supposed to be a straight line, right. So, the first ray I draw is the ray that goes through the entrance pupil. That's why it's called the entrance pupil. That's the first ray. I draw it as if it's going up to the entrance pupil, but of course at the very first element with power I have to stop because the ray is going to bend then. At this point I don't know how it bends, I only know that it bends, okay. What I did next was to say, how does the ray exit the system? Well, it's the chief ray, we are plotting the chief ray, so this red color is chief ray, okay. I know that it must reach the extremity of the image plane and it appears to come from the center of the exit pupil. So, that is what we have drawn here. Again, we have only drawn the ray from the last lens to this point, because before this lens it of course would have bent and arrived here. What can I draw next? Well, when I go back to this first part, so this is the first part that I traced, it is going to bend at the lens. What's the next element it happens to go through? It happens to be seeing the aperture stop next. Now we know the chief ray has to go through the center of the aperture stop. So, this is the center of the aperture stop. So, I am going to draw this, right. And now I have this point over here, this surface, and let's just consider all of these lenses to be straight lines, okay, because we are seeing thin lenses. So, I will draw it up to this point, I will draw it up to this point. Now, I can finish off the last part because I have this point over here, I have this point over here. So, clearly these two are going to connect. So, I plotted this ray from the extremity of the object to the first lens using the fact that ray must extend to the center of the entrance pupil. I plotted this ray next, this part of the ray next, from the edge of the image appearing to come from the center of the exit pupil. If the aperture stop had been here, I would have plotted that next, saying this ray, this one here, it should have gone through the center of the aperture stop, but the aperture stop wasn't there. So, I took this part of the ray through the center of the aperture stop. So, now let us look at this ray. This is the chief ray. Is it doing everything we know the chief ray ought to be doing? The chief ray needs to go through the center of the aperture stop, needs to be coming from the extreme point of the object, hitting an extreme point of the image. The ray that is hitting the extreme point of the image must appear to come from the center of the exit pupil. The ray leaving the extreme point of the object must appear to come from the center of the entrance pupil, right. And if we look at that, this ray that we have drawn meets all those requirements, okay. Now, my drawing is not very accurate. Of course, each of these segments of the ray are straight lines, because we know that light travels in straight lines in a homogeneous medium, right. Okay. Okay. In a similar fashion, can you now plot the marginal ray, right. So, that is the ray that starts off from the object point which is on axis. So we want the ray starting off from here. Yeah, that's why I've drawn it in segments. No? His question is, how do I know how it bends A to C? I didn't draw it directly A to C, right? If I had said, let me trace the chief ray and I start at a point and then I just do this, you can ask, how does it bend? The reason we're drawing it in segments is, from the information given here, you're just given a figure, I haven't given you any of the data. How do I know how much it bends? That's the reason we're drawing it in segments. Okay? So you understood how I draw the first segment. I drew segment A by starting from an extreme point on the object and drawing as if that ray were hitting the center of the entrance pupil. At the first lens, it's going to bend. So I stop at that first lens, right? What I next did was to draw segment B, saying that is arriving at the extreme point of the image and it should appear to arrive from the center of the exit pupil. So I drew that segment. Then I came to segment C and I said, well, after this lens L1, the first lens, see, each segment is a straight line. That's what I said, right? My drawing is not good, but within a region of homogeneous refractive index, they are straight lines. So A is a straight line, C is a straight line, D is a straight line, B is a straight line. Like it should not bend in between, right? It has to follow Snell's law. If there's no change in refractive index, it should not bend. How did we draw segment C? Well, from this point, we know the ray must go through the center of the aperture stop, since the next element is the aperture stop. So I know I have to draw a straight line from this point to this point. And so I continue that straight line on till I reach the next element with power. Does that answer your question? Is this clear to everyone, or are there any more doubts? How can it go straight to the entrance pupil? Does it not have to bend? So his question is, does it go straight? In order to draw segments of the ray, I have to assume, this is the definition of these rays. They appear to come from some direction or they come from some direction. But I cannot ignore the fact there are elements with power. If I were to draw it straight, in fact, I would not be able to draw it straight. How would I be able to draw it straight? Because if, let me just change the color here. If I were to do what you're saying, that means I need to draw a straight line from this point through the center of the aperture stop, and this is the chief ray, so it also has to go through the center of the entrance pupil. I can't draw a straight line through these 3 points in any case, can I? They don't lie on a straight line. So I think the confusion you're having is you're thinking, when we gave our definition of the chief ray, we said this is a ray that will either travel through the center of the aperture stop or appear to travel through the center of the entrance pupil and the exit pupil. The ray may actually travel through the center of the entrance pupil in the case where the aperture stop and the entrance pupil are the same element. Right? Let's say I had a system which didn't have 3 lenses, had just 1 lens. Right? I have an object and I have an image. The chief ray here will go through the center of this. I would do this. Now the lens is both the entrance pupil, well, not both, it is the entrance pupil, it is the aperture stop, it is the exit pupil also. So in this case, the chief ray is actually going through the center. It is going through, physically going through the center of aperture stop, entrance pupil, exit pupil. But in a case like the one we are looking at now, there are 3 lenses. The entrance exit pupil are not the same as the aperture stop. The chief ray will appear to go through the center of those 2 elements. But obviously it cannot, because you have to take into account the fact it bends whenever there is an element with power. Okay. That's the reason why I draw this ray in segments, because I know the first segment what it ought to be doing, and I draw a straight line from the extreme point of the object to the center of the entrance pupil, but I have to stop the moment it hits an element with power. I say this is the direction this ray would take, but there is an element of power here, so at this point it is going to change direction. Now I want you to carry out exactly the same exercise, but for the marginal ray. Can we trace this part, section D, using some part of our definition? And we can't. This ray happens to lie in a zone where there is no way to use the definition to help us trace it. So this is not the way you would actually trace a chief ray through an optical system, because you could then argue, what happens if I have 20 elements or 30 elements? It's going to become very complicated. You can always trace out the first part, because if you know where the entrance pupil lies, you will say here's the starting point on the object, here's the entrance pupil, and I know the direction it should go. But this would be a very cumbersome way of actually tracing a chief ray through the system. So this is not how people trace rays through the system. The way we trace rays through the system are using the methods I talked about in yesterday's class, which are the YNU method or the YUI method, or the matrix method, which we will start either in today's class or in the next class. Those are the ways you actually calculate and trace a ray through the system. This exercise is just for you to get clear on these definitions, right? It's for you to get clear on the definitions of chief ray, axial ray, as well as entrance exit pupil and aperture stop. That's the purpose of this exercise. Okay, so I want you to carry out the same exercise now, but for the axial ray. It's called marginal ray. It starts from the axis point, right, where the object and the axis point intersect, right? But it's called a marginal ray. Why? It goes through the edges of the pupils. It goes through the margin of the pupils, right? Okay, will you try to sketch that? Same procedure, do it in segments, do the segments you know for sure first, and then try to fill in the gaps. So what would be the first segment you would draw? You need to start from this point, the object point on the axis, and that ray has to appear to travel towards the edge of the entrance pupil. So our entrance pupil edge is here. So I would need to draw a straight line starting from this point and heading all the way to this edge. So I'm going to start off like this, but the moment it hits an element with power, I know the ray is going to bend, so I will just continue the rest as a dotted line. Okay. So at this element, the first lens of the system, the ray bends. So let's leave it there. This next segment I am going to draw is the one that contributes to the image here, right? Now this ray has to come from the edge of the exit pupil. So I should draw a straight line all the way from this point to this point, but of course I know there is a lens over here, this lens here. So the ray would bend after this lens and then come in that direction. So I draw the dashed line and I ignore everything, and then from this point onwards I draw a straight line. That's supposed to be a straight line, okay? So I am confident that I've got the slope of this part of the ray accurately. I've got the slope of the first part of the ray accurately. I still have two segments left to draw. Now let's go back to what happens to the first segment. The first segment was traveling happily on to the edge of the entrance pupil, and then it had to abruptly stop at lens L1 because it has to bend, it has to obey Snell's law here, and it has to go through these refractive surfaces. How does it bend? Well, it so happens in this particular case the next element is the aperture stop, and I know that the marginal ray has to go through the edge of the aperture stop. So, all I need to draw a straight line are 2 points. I have got my 2 points. It starts from this point, it has to go through this point, and I draw it as a straight line, and I continue that straight line past the aperture stop till I reach the next lens of or element with power. And now it's easy for me to draw the remaining part because I have a point here and I have a point here. There's nothing in between that affects the bending. Yes, the entrance pupil happens to lie there, but the entrance pupil is a virtual concept. It's not affecting the direction of the ray. So at this point it's going to bend like this. And luckily, because my drawing skills are not good, you can see you had a concave lens there, and it's nice to kind of see that the ray didn't converge as you normally draw when we draw a standard convex lens. It actually diverges, and you're not surprised by that behavior because you do see a concave lens over there. Okay? Okay. So, with this exercise, I hope this whole idea of these rays and the entrance exit pupils and the aperture stop become a bit clearer. What physically exists in your system are all the elements with power, plus you may have mirrors. If the mirrors are planar in nature, they do not have power, they only change the direction of the optical axis. Right. So, in all the examples I have been drawing, I draw a straight line through my system. That's always how I start. I draw that straight line and say this is the optical axis of the system. If I were to put a planar mirror into my system, I am changing the direction of the optical axis. Okay. I could have a mirror with curvature, in which case that is also an element with power. So, the moment there is an element with power, the ray is then going to change direction, its slope is going to change. What the aperture stop does, it's tell us what's the maximum cone of light that goes through the system, and this immediately tells us how much power is reaching a point on the image plane. But as we saw in yesterday's class, it's not just power that gets controlled by aperture stop. You see that it also controls some very important features like the depth of field and the depth of focus, and I said also it controls things like aberrations.